Kieran Shepherd, Security Solutions Engineer for F5. What have you got to talk to us about?
Well, I thought that was really interesting, especially some of the attacks about, sanitizing the input on the API, because these were attacks that, we were doing 10 years ago on shopping carts where they failed to sanitize that final piece of input. And you could have some great fun. We'd move the decimal point one place over on the final piece and, your £100 thing.
Shift left.
Exactly, yeah. A better form of shift left. So, it's funny how history repeats itself. I'm going to keep things fairly high level, but as Philip says, I'm going to get my geek on later on in April, where we get some real I get my CLI skills on, and we can do some demos, so just to make people aware of that. But just wanted to highlight, we talked about this sprawling applications and lots of different apps. F5 Labs did a report last year, and the average number of applications that an enterprise organization uses is nearly 1,000 applications. And out of those, about a third of those, they came back and said, well, this third is mission critical. These are the ones that they can't go down, we can't move into the cloud, they're core applications. So just from the number of apps alone, you can start to see how things can get out of hand. And especially as you mentioned earlier about the reducing skill set that you've got available to you within, all forms of industry. The other key thing to remember is just applications have changed. They're not the same shopping carts that you put stuff into 10 years ago. They're not a simple application on a hosted web server. They're now split into many, many multiple back-end applications, microservices talking to each other, as you mentioned, east-west. They're living in different clouds. I haven't met a customer these days that's just concentrated on one cloud. They might be using Azure AD, and then maybe some AWS, maybe some Kubernetes in Google. Maybe they're another retail organization. They don't want to line Amazon's pocket, so they won't go into AWS. There's many different reasons, but people will be using multiple clouds or multiple data centers. And then, the common thread among this conversation has been around that API. And again, APIs aren't just SOAP XML or REST. They could be gRPC. There's a number of different APIs to get your head around as a developer and as someone who tries to protect those different APIs. So, just those couple of slides alone, I think, really highlight the complexity that we are, delving into these days. I think this simple slide highlights it. If you look at an application on your phone, as a non-technical customer, you probably believe that application just lives in, let's say, the shopping cart that you're going to. But actually, different pieces of that application are connected via APIs to different data centers, maybe edge cloud services, where they're, looking at real-time shipping location, content delivery networks for static content. So that application, you can very clearly see from that picture how it's kind of sprawled and split across.
So how can you protect all these different APIs and applications when they live across so many different environments?
They do. So if we look at kind of the journey from data center here, then moving to hybrid cloud, with a bit of data center, bit of cloud, and then as we mentioned, customers moving into this multi-cloud. Gartner coined a term a while back called distributed cloud, and they're saying the next generation of cloud computing is using the advantages of the cloud but being able to leverage them in almost like a single super cloud. And that single super cloud really is kind of edge services. So we've heard in the past about moving your content to the edge, but now we really need to move applications to the edge, because those backends, as you said, could be multiple different clouds. And that's really the key point now, is where we can start to apply our security in that distributed cloud. There's a number of things you can do once you've got that key control point, and one of those is API discovery. It's something we do. We utilize machine learning and artificial intelligence because developers are constantly just firing new features. Long gone are the days where you released a new feature once a month. Some applications release new features 2, 3, multiple times a day. So you need to keep on top of understanding what's going on.
But how can you carry on protecting applications APIs if they keep on evolving in this way? If
Well, having something learn what's changing for you, like machine learning, is monitoring your application and saying, well, there were 15 APIs going to that shopping cart yesterday, there's now 17. Okay, something's changed. At least having the knowledge, right, you've got 2 new APIs, 2 new resources, and then you can apply some protection to them. But that's where teaming up with vendors like Psycognito and NoName really helps, because as Philip said, they're not just looking at those 2 new APIs, they're looking at how do those APIs work, what methods should be applied, what does the business logic, and we can take that input and then place it into our distributed cloud and actually then start to lock that down.
Philip, is machine learning and AI, is that something of a silver bullet in these situations?
Well, I think if you look in general and apply like ML and AI to the security problem, I think there's a lot of data, right? So ultimately security, I think, is a big data problem. And there's the idea of getting the signal from the noise is where machine learning can really come in and help. So the idea is there's a lot of communication happening, but what is like very important at this particular time to protecting my application, and if you can sort of use that learning through ML on those data sets, I think that's really, really going to be helpful.
Right.
Absolutely, yeah.
Kieran, continue.
And I guess this really just reiterates the point around, shifting left. There's an important statement there at the beginning, addressing every vulnerability at the release cadence of the DevOps team is impractical, i.e. you're not going to be able to patch everything as it comes out in real time. But there is a set of common controls that you can apply to web applications. And the problem in the past is those controls normally get placed after the event. I.e. a developer's built an application, he throws it over the fence to ops, and then someone says, hey, your firewall's broken my application. Why are you causing the business a problem? We're just trying to apply some security. So shifting left really helps here, because if you can give the developers the tools that they use in their day-to-day. So instead of saying, right, you have to apply a firewall policy, it's a WAF, you have to do X, Y, and Z, they don't want to hear that. But if you turn to them and say, look, there's this thing in GitHub, and when you build your app, you just pull it down, and they go, yeah, okay, whatever. It's just another step in their tool. They will do it. It's frictionless. We see this with clients a lot as well. When people had to install agents on their browsers or install an extra piece of software, it never got done. But if you built the security into the code within the browser and it was frictionless, it was adopted very, very quickly. The final thing really is, making sure security for the different service needs are covered. Now, what I mean by that is, again, you can't just blanket security, because it just becomes a headache to some people and it becomes a barrier. So, what the security that NetOps requires is going to be a completely different security that DevOps requires. And if we look at this journey here from the customer on the right, moving through to the code, the application on the left, they'll move through some network services, some DNS, maybe some gateway load balancers. This is what we would call our typical north-south traffic. But then they might move into something like Kubernetes. That's almost a network within itself. Kubernetes has an ingress controller, a little bit like a load balancer, talks to its different pods. But developers don't care about this. This is just, this is an abstraction for them. So this is where we go back to, the point before. Don't give them a headache. Just give them the tools they use. And if, the default ingress controller for Kubernetes happens to be Nginx, which is an F5 company. So if you can apply your security at those different levels, at the ingress controller or at the pods for the developers, it makes sense. If you can do something different for the NetOps guys up front, further out into stack, that also makes sense. But you're not giving them a headache. You're just giving them what they use in their day-to-day.